Okay. So yeah, some of the questions that came out of the last session, I guess there was maybe a little bit of confusion with the labs, whether or not we were going to do labs during the individual sessions, and whatnot. So first, I guess a simple show of hands: did everyone receive the keys to the labs that I sent out directly following the last session?
Yep.
Okay. All right. Good. Um, looks like maybe Matt hasn't. Okay. Maybe Matt's just not able to click right now. So all right. So as long as you guys got the keys, that's the important part. Obviously, you see the time that each session takes. We don't necessarily have time to walk through the labs in and of themselves, and understanding that there are different skill levels. Some people move faster than others. They're really designed as more of a self help tool to make sure you're understanding the concepts that we talk about each session more than they are kind of in a classroom setting where we'd all be sitting in a room, hands on computers, working through problems together. Okay, so that's what the labs are designed for. By all means, as you complete the labs or as you walk through the labs, if you run into issues or problems, feel free to email all, right? And so I usually find that if somebody is having a problem, that usually means multiples are having somewhat the same problem. You can generally help yourself. And being an Android class, we should all be extremely familiar with open source and community support because that's really the premise that this is built on. At least the architecture is built on. Okay. All right. So tonight we're going to go through another two sections. We're going to try to get through, as you probably tell, two sections a night. There are a total of 10 sections. Tonight we'll be employing secure mobile app development strategies and accessing local processes and device security. So, as I said in the introduction, you guys are from what I understand, just native coders. That's what you do for a living every day. And I'm looking forward to, in some ways, learning from you as much as hopefully you'll learn some of the security aspects from me. Okay, so as we get into the meat of this, by all means, if you run into maybe a better way to do it or what have you, by all means, let me know because that can only make all of us better at what we do. Let's dive right in. Are there any questions to this point about anything? We're ready to hop into it. Okay, all right, good deal. Okay, so Monday we discussed the basic principles of security. Right, they're basic tenets that, regardless of subject matter, whether it is secure programming, secure network design and architecture, secure approach to facilities and facilities management, they are the same pillars that the security is built on. We will now get a little more specific into software design and software application and deployment. However, they're still going to build on the basic bedrock that we laid on Monday, and as you'll notice, as everything expands, they're just still building on those core basic tenets of security. Okay, so it begins with best practice, right? We've heard the term best practice almost to the point that it becomes noise, or as my boss calls it, dolphin speak. When I start talking to him about security, he's not a security person by trade or by nature. I happen to work for somebody who is his background is in acquisitions. He just landed in and acquisition field with the concentration on information assurance and information security. So when I start talking to him about, okay, so why don't you understand this? Why don't you know this is how we do things? He calls it dolphin speak, and I have to slow it down and back up a little bit and start using smaller words, more to his cognitive level. But that's where it all starts. It starts with the best practices, knowing what the best practices, knowing the right way uh, it is applied in business to do something. Get the foundation set first, and then you can start bending and playing and finding your own. Finding your own best practice with it. That's interesting. Let's start there. So the idea is if you let best practice be the guide, that everything else should fit, right? And the good part about best practice is it changes. It's fluid. It is not static. The way we do things today is not the same way that we did things 10 years ago. And some of us would agree that that's probably a good thing. And of course, some of us would probably indicate that it might be a bad thing, right? Telework, for instance, would be one of those subject matters that I call them the old guys, right? They just don't understand the idea of teleworking, of not going into a building every day, but yet still producing a product. Do any of you guys telework by chance, or are permitted to telework? Your organization allow you to telework or work from home at times? Okay, well that's good. I'm a firm believer in teleworking. I think you're going to get the best uh, product out of employees when they're in a comfortable surrounding. And how much more comfortable can you get when you're rolling out of bed and essentially not having to do anything but walk to a home office? Studies have shown repeatedly that teleworkers are their productivity level is almost twice those that have to sit in an office all day long. And we see it in practice almost all the time. Between why doesn't Bob get as much work done as Jane, and Jane's never here? Well, because Jane doesn't have the distractions of the office place and just the natural issues that come with that. So we got a little off, but that's okay. But that's the idea, right? So you build the bedrock of security, and it's all built on three pillars, right, or what we call the CIA triad. The CIA triad: confidentiality, integrity, and availability. You cannot do or affect one portion of the triad without affecting the other. uh, we as security professionals must always be cognizant and maintain focus on balancing the triad. Now, that is going to vary from organization to organization, project to project, and subject to subject. Whatever the data owner indicated was the goal of that security focus, whether it be email or databases or application design. That is the focus that we have to keep, but also bearing in mind that as we maintain focus in whatever we've been directed, that you're going to affect another portion of the triad. For instance, encryption. I think we would all mostly agree that encryption is thought of as primarily a confidentiality based event, right? I'm trying to obscure or hide the true contents of the message. So the encryption algorithm that I choose needs to be strong enough so that I meet my mission goal. Nobody should be able to read it. However, the algorithm should not be so resource intensive that it uses all the available system resources and lowers the availability to the point that the system cannot be operated. Right, so I have to strike a balance. When is the right time to employ which? Right, so that's the CIA triad. You will definitely throughout the exam or any other security exam that you take will concentrate and focus you in to the CIA triad: confidentiality, integrity, and availability. Okay, so there are offshoots of the triad that we deal with that are primarily they're centered around authorization. What permission level am I going to allow that process or that object or that subject into the ecosystem? Authorization comes in three parts. It's best, easiest to remember: ID, authn, and author. Okay, three parts: ID, authn, and author. You cannot do them out of order. You must first identify yourself to the system. You then authenticate to the system, and then you are granted authorization. Okay, so username is your identification. I'm going to assert that I am somebody. And I do that with my username. Then I need to prove that I am that somebody. So the way I prove I am that somebody is I authenticate with my password. Once the system or the ecosystem hits a match of ID and authentication, it will then authorize me my privilege level, whether I'm a general user, whether I'm an administrator, whether I'm a system service. It doesn't matter, right? It fits regardless of the content. Okay, so ID, authn, and author. The last pillar that we deal with is non-repudiation. Non-repudiation is a lot of syllables just to say that I can't deny it. Okay, so uh, it, it makes us sound like we know what we're talking about when we throw out a big word like non-repudiation. Uh, all you're saying is that I can't deny that it was me. It takes away the ability for me to say it wasn't me, right? So that is the essentials of the triad and how we act and react within a secure infrastructure and a secure ecosystem throughout whatever model we're dealing with. Okay? Are there any questions over that or anything up to this point? I think you've probably heard this probably 1,000 times, depending on your background. Okay. All right. So what do we do? So now we understand we have the triad. The triad is there for a specific reason to do nothing more than protect the ecosystem. Uh, how do we employ that basic bedrock or that basic best practice into what we do? So if everyone has had an opportunity, I'm assuming if you got your keys to log in to the course website. There are some really good, some of them, and some of them are kind of cheesy videos out there. However, there is one video that I did find that touched on this particular exact subject matter. So figured, okay, so maybe we'll give it a shot. If you find it ridiculously cheesy, let me know. But maybe it'll put together for you some different ideas.
Is there supposed to be?
Okay. Um, so I'm seeing a couple of comments. There was no audio or video with that. Interesting. Okay. So apparently the screen capture didn't capture what it was supposed to. Okay. So Todd saw video. Some saw no audio or video. Some no audio. Okay. Okay. Interestingly, so there's a mix. So some of it was captured, some of it was not. However, it is a video within the series in the course login, understanding the CIA triad. You can go in and take a look at that. And I will, once again, during one of our breaks, I'll play with some of these settings and see maybe if I can figure out why the audio didn't work for everyone. Okay, so now that we understand the triad, now we apply the triad to a specific subject matter. In this case, it is the application development. So when we're talking about application development, we apply the principles, or once again, the best practices around everything that we do. Right? So we talked about on Monday that one of the core competencies of the Android platform is it operates within a sandbox. Right, every application should be operating within its own realm or domain. Excuse me. That by ensuring that it's not breaking out of its sandbox, that only the adequate permissions were applied to the application within the coding structure, that is employing the practice of least privilege. Okay, so uh, we understand the practice of least privilege every day within a classical AD architecture, and within that architecture, we make sure, for instance, that we have an accounts receivable and an accounts payable, and that no one administrator has permissions to do both actions. Right? You can't receive an accounts receivable and the same person pay out an accounts payable. We separate them, and that is ensuring that we are practicing least privilege. We assign them roles, and they should not be able to break out of those roles. So if you aren't if you don't have a question or you don't have something to interject, if you could mute your microphone to make sure that everyone else isn't hearing you, that would be great. Okay, thank you. The practice of least privilege, that is the act of sandboxing our applications in and of itself to make sure that you have applied good, best business practice to your applications so that the application isn't gaining unauthorized levels of privilege. With next, we would move into more of an integrity-based function, less confidentiality or availability. We talk about app purveyance. App purveyance is nothing more than making sure that it's resilient to attack. Right, taking the correct steps to ensure that it is tamper resistant. That somebody we saw how easy it was, the simple 7 steps to break into an app. Right, so we begin to practice what's known as security through obscurity, that even if since you can break it apart, that we hide some of the things, some of the calls and procedures and services within the obscurity of the code to make sure that it is tamper resistant. Then we move on into data encryption. Data encryption, as I said, is most commonly associated with confidentiality. Encryption, especially when you're talking about mobile devices, being that they are a lot easier to walk away with, for instance, than a desktop computer, your employ of encryption becomes more paramount because you're constantly dealing with essentially sensitive data at rest and making sure that that data is in a reliable, safe, secure state as the user that is employing your app would indicate or trust that you have employed. And then access control. So access control is one of those things that kind of touches on all three pillars of the CIA triad, more into the integrity and the availability space, right? Have I protected the app appropriately from unauthorized use? You want to make sure that you're maintaining the integrity and availability of the apps and the app's resources. But it does touch a little, into the confidentiality realm, because once you have breached data services, and static data, now you have a confidentiality problem because you have unauthorized access. Okay, so access control, like I said, is one of those that absolutely touch on all three pillars. So that is what's important to understand is not to just lock access control into it's just this or it's just that. Your user or your customer or the organization will dictate the level of access control and why it's important as the project is initiated. So you heard me say it, I guess, at least once at this point. Security through obscurity. Is that a new term for anyone? Has anyone never heard security through obscurity? Okay. All right. Good. Like I said, we start getting to a new term or a new piece of subject matter. Absolutely, stop me and let me know so I can offer a little more explanation around it. Security through obscurity is simply right. It's just making sure that you're keeping the system secure by not exposing all, right, and keeping the mechanisms confidential. Right? So knowing that it's near impossible to completely hide everything that is going on throughout the application or the ecosystem, we do want to add speed bumps, right? Slow them down to the point that we're not giving away everything easily, right? They should have to do some work to find the security mechanisms that we put in to the design elements. Okay, so that's the object of security through obscurity. It's not going to stop them. The hope is that it at least slows them down. And then we move to it's very similar to security through obscurity would be security by design, right? So nobody, I don't think, would go and build a house, for instance, without a set of blueprints, right? That would just be, I guess, foolhardy, right? So I'm going to have a set of blueprints. I'm going to have a plan. I know where the walls are going to go. I know where the front door and the back door goes. I know how much space I have for a living room, and bedrooms, and kitchen, maybe a laundry room. That is the design. We all know it changes and it fluctuates. But once you actually get into laying the foundation for the house and framing it in and putting a roof on it, things are going to move. But basically, the end product looks extremely similar to what what the design was. Right. So when we correlate that to what is security by design, it's the blueprint of how we're going to do it. Right? So we're going to apply least privilege. We're going to apply separation of privileges and separation of duties. We're going to provide fail safes. And most importantly, as we touched on Monday, we're going to keep it simple. Okay, the more layers that you add, the more complexity that you build in, uh, it has the counter effect of what your intent is. The more complex something is, the more holes that you have to fill, and the more you have to keep track of, and inherently you're making the ecosystem weaker rather than stronger because you think that you're adding all these layers of complexity. In actuality, you're really just opening more holes than you're able to keep track of. Okay, so you see highlighted there, no single point of failure. We talk a lot about that in network architecture and physical and environmental when we're designing buildings. That you don't want a single point of failure to bring down everything. You should make sure, give cognitive thought to the idea of not having a single point of failure within the application design. Right? And part of that comes with keeping it simple and layering in defense and depth, but don't make it overly complex that you can't keep track of. Right? And then, most importantly, check and double check. Right? That cannot be really stressed enough, especially in application and software design and management, is to check and double check everything. Right? Do your code reviews, do your regression testing, make sure that that what you think is there is actually there. Don't rely on your eyes to see it. Pull the team in and have everyone reviewing everyone else's work to make sure that you've met the design requirements. So, the software development lifecycle. I think we've seen this picture before, which is a little larger. However, it's more of the same, but it can't be, I guess, overstressed. Right? It should be how you're doing business. It shouldn't be haphazard, fly by the seat of your pants to get a product from the requirements phase out to deployment. It should be methodical in nature. Even if you're just an independent app designer, you're not doing it for a large organization, you still should take very deliberate steps from A to Z. Go through the requirements, identify the requirements, put them on paper, do a sketch of what the final product is supposed to look like, rather than um, guess at it all along the way. Make sure that your design elements are as intended, so that your as built meets your as design. Then move into the overall development and regression testing. Right, you should have beat on every aspect of your application before it ever hits deployment. You can't rely on the Google Store, the Google Play Store to do your testing for you. They're testing for basic security tenets and reliability and functionality. They don't know every nook and cranny and bit and bite that you put into it. That's supposed to be your job. At the end of the day, it's your responsibility to protect your end user throughout the life cycle of your application. Once again, you see the highlighted words. Those are real good testable information. You see a lot of things repeating over and over again. Perform the testing, reducing the attack surface. Perform security review. Perform security review. This should be worth at least 1 or 2 points on the examination itself. They're hammering home for you, or at least trying to hammer home for you, the importance of review and testing. Okay. Any questions there? Okay, good. By my clock, we're about at that half hour mark or so. Time to take a short break. So we're gonna take a short 10-minute break here. Let you get refreshment, whatever your need is, and we'll be back in 10 minutes. Okay. All right. Welcome back. Hopefully everyone was able to grab a quick refreshment, whatever that needed to be. Sorry about that. My dog apparently has gone crazy. Okay. Where we left off. So now that we understand the pillars of security, the CIA of security, we know that it's paramount in our approach to everything within the ecosystem. We also need to ensure that we're meeting the business requirements and the specifications for design. Uh, and even if you're an independent programmer and you're doing this just out of your basement for fun or just to make a couple extra dollars, or you have the next bright idea, you still need to understand that the requirement of what you're doing and the specifications really should just, like I said, be written down on paper up front, posted on a wall or a pegboard to always remind you of where you're starting and where you should end up, uh, even though it's going to be in a less formal manner than if you were performing it for an organization. Okay. We talked about the differences between what is a business requirement and what is a regulation, what is a standard. Being cognizant of all of them is important throughout the entire process. It gives you an example, right? Preventing a copy and paste or a screen capture for medical labs because of HIPAA regulations um, prevent it, right? So that's what you're focusing on. It's almost like we have to know a little bit about just about everything, or at least know how to go and research it to know that our applications and our software is going to meet the regulatory requirements. You need to ensure that your product, every phase or every element, every security um, application that you employ within the ecosystem itself is testable. It should come out with a predictable result. Unpredictability leads to instability, and then stable obviously will lend itself to insecurity. So they all kind of fall upon themselves. It begins a watershed event, right? So you should be able to test against with a predicted outcome the security requirements that you have built in based on the regulations and the business requirement specifications for each one of your applications. And then documentation. Documentation is one of those things that is often forgotten, but it is almost as important as the triad itself, right? Document. You got to make sure that with every test that you record the unsuccessful tests as well as the successful tests, right? To show that you have met or at least strive for the most secure architecture possible, so that down the road something could present itself, right? That you tested against before, you read the after action to it, and said, "Oh, yeah, we ran into that before, and here was the problem." So it will take a lot of time and expense. And remember, we talk about resources being time, people, and money. A lot fewer resources to correct an issue if you have thoroughly documented up front everything and as you go. That is one of the things that we find, especially within the software development community, that is sorely lacking. is the documentation of the process and the trial and error and the give and take that it took to get a particular piece of software and application from zero to hero. So documentation plays a big role in just about everything that we do when it comes to secure design. So as we move through the phases, right, of the software development lifecycle, uh, we need to examine which principles are we employing and at what level. What do they mean, right? So we talk about openness, fail-safe, least privilege, resource economy, mediation, but really, what do they mean? Have we successfully applied it? Right. So openness, right? So assume that attackers have all the information that they need to successfully exploit your application. Once you make that assumption that the kimono is open, it gets a lot easier to defend against. Right, you just know that I have a wide open attack surface, so I need to anticipate at every level. Fail safes. Once again, no single point of failure. Right, make sure that just one piece of instability doesn't bring down everything with it. Least privilege. Ask only for the permissions that are absolutely required. Right, remember you are being entrusted through the download of these applications by your users. That you are not going to put their data and a lot of times their business sake or their livelihood at risk. So you're only going to execute with the minimal set of permissions necessary to get the job done. Resource economy. So that plays once again to the third pillar of the CIA, right? The CIA triad, the availability. You don't want your app to be such a large resource hog that it renders the device or devices useless, right? Be prudent with the services that you're requiring, whether they're local and isolated or whether they're shared. Understanding that the more resources you require, the more horsepower the device requires, and the device itself is a finite object, right? You're not going to put more RAM, for instance, necessarily into a mobile device like you would a desktop computer. A little more trying and difficult. And then finally, mediation, right? So check and double check your code, right? So we spoke about it before, but it bears repeating, right? So make sure that you are checking and double checking through every phase of the software development lifecycle. It will only make your job easier once you move from phase to phase and then finally into the deployment and maintenance phase of your design. The development phase itself is probably the single longest phase of all. Right? Some would argue, and I think I would join in, that going from the concept of what I want to do and researching the requirements, whether they're statutory or regulatory or what have you, is fairly straightforward, fairly simple. But then when I get into the design and development, those take the most time because what I sketched out on paper may not necessarily even be capable or able of being carried out by any or some devices. If I want to mass market someone, I need to ensure that it can be used by the largest audience, and that when especially becomes issues when it comes to in the development phase. If you design something that's only going to work on the top of the line, most expensive device, you're leaving out a whole subset of potential revenue and potential users. So once again, if you don't build too much into the application itself and make it too complex, you're guaranteeing yourself somewhat a larger audience to consume your final product. So when it goes to code review, there are many different avenues that can take. Some organizations, some areas of either government or the private sector require either a manual code review or sometimes you hear it called a peer review versus some sort of automated review. So you'll have a bevy of tools to choose from. Uh, I've highlighted, for instance, Jupyter, Agile Review, and Garrett for a very particular, specific reason. They are open source, all distributed under a GNU license, which makes it extremely easy for CompTIA to maintain their vendor neutral status. Right, so when you get into IBM Collaborative Code Review Tool, now you're talking about a commercial piece of software. It's hard to test against that, for instance, because they would be breaking the vendor neutrality of the exam. So understanding that your most common offenders, right, through the exam will be Jupyter, Agile Review, Garrett. Those are the open source manual review processes that are there. Lots of community support to deal with, to facilitate manual or peer review. Then moving into the automated reviews. Now those generally you'll hear them referred to as CASE, like computer aided software engineering. Um, those are used primarily for really people like me, right? That don't know and is not a true born bred expert at writing Java or writing Ruby or writing C Sharp or C. I will employ case tools that is going to check against the best practice. Right? It helps bridge the gap. It knows what the code is supposed to look like. It's gonna flag general code flaws against known standard. Once again, check style and find bugs. Open source. You can go and get them from Forgeman or SourceForge. Download them, use them without license or issues. So once again, it's very easy for CompTIA to test towards because they won't break their vendor neutrality. So those are what you'll see referred to as CASE, computer aided software engineering. They help bridge the gap between coding professionals and security professionals because often they are not one and the same individual. And then you decide on a method. One single method is not endorsed over another. It is absolutely endorsed to implement multiple testing methods. Whatever the organization, whatever you, the developer, deem the best application of resources, whether it's pen testing, whether it's fuzzing, whether it's dynamic validation, risk-based testing, find several, employ several to ensure that you have balance in the triad itself. I've highlighted once again the most logical offenders. Fuzzing you will see throughout the test. Really, all fuzzing is simply put, it's throwing every known variable at a piece of source code and looking for an invalid response. Right? So fuzzing is exactly that. I'm using fuzzy logic. I have no finite idea of what the outcome is going to be. So I'm going to throw everything at it and see what I get. Right. So that is fuzzing. Penetration testing or pen testing is heard often. So I don't really think we need to go through that. Regression testing. Regression testing you should see at least once or twice through the examination. So those would be the three when preparing for the exam that concentrate on pen testing, regression testing, and fuzzing. Okay. Are there any questions up to this point? Okay. None. Okay. All right. So we'll move out of the development stage, which, like I said, is awfully often the longest phase of them all, into the deployment phase. So deployment should be your celebration, right? Once the Google Store has accepted it, it's ready for mass deployment. You're about to reap the benefits of all your hard work. It should be a time to relax, right? Well, okay, so maybe not completely, right? You don't want to let your guard down at this point. You need to plan, right? Plan for the worst, right? I know that I'm always accused of being a pessimist. Uh, Not necessarily. Well, actually, I think it kind of comes with being in the security business. But I plan for the worst case scenario and hope it never happens. Right. So if I plan for it and prepare for it, then if it does happen, it's easy for me to respond to. That's what you need to prepare for once you hit the deployment phase. Once you're ready to get your product out there, plan for the unforeseen. Right, being that 0 day exploit against your app that you don't have a patch for yet. What are you going to do? How are you going to collect report? How are you going to keep in contact with your customer base? Right. So most importantly is to before you hit deployment, before it hits the Play Store, establish a issue reporting system. Right. So I've added here right the top 10 open source bug tracking systems. Right? Those, whether you're using Bugzilla, which is probably the most common one out there, or any of the others, have it established before you hit the Play Store, not after. Not after everything is going haywire, and you're trying to keep emails and um, correspondence with your users, on napkins and what have you. Show the same attention to detail during deployment as you did prior to deployment. Right? So that is the deployment phase in and of itself. Right. So prepare for the worst and hope it doesn't happen. But if it does, have a series of checks and balances in there to be able to react promptly and swiftly to anything that comes up. And then moving into the maintenance phase, right? So the maintenance phase is varied. It's going to depend thoroughly on the app itself, the demand for the app. But however, you should go into the maintenance phase with a plan, right? I'm not going to release planned patches every 3 months. Am I going to release planned updates every 3 months, or biannually, or once a year? Follow and make it predictable for your users, right? We know Microsoft is going to deliver patches every Tuesday, right? So sometimes I think they deliver patches just to write a patch, and then they have run out of patches. But nonetheless, they have a schedule. I know on Tuesday that I'm going to receive something. So set your standard up front before you get to the maintenance phase. It adds reliability and surability to your customer base that this isn't just haphazard, that you're just kind of throwing it together as you go. And then also you need to ensure to keep an eye on the releases of the next Android updates. When are they going to update the base operating system? Generally, developers are part of the beta test group and the alpha test group, so you know how your app is going to, or at least have an idea of how your app is going to behave with the next standard release. So it lets you get ahead of the curve prior to the next mass deployment so you're ready to issue the update to your app to close any holes, security issues, or even just compatibility issues that might arise with the next update. So this is the cocktail napkin, right? This is you still have not necessarily put finger to keyboard at this point. This is all part of the documentation, right? Is the architecture diagram or the data flow diagram, if you will. How does everything act and react and interact with each other? What are the resource requirements? Where are the resource requirements? Is it local? Is it in the cloud? Is it? Are you relying on some service, some other outside service for your security requirements, whether it be an encrypted network or log storage or having to call back into an outside database. But if you have it all out on paper up front, then once again it makes the design move a lot quicker, a lot smoother. Once everyone knows what sheet of music they're supposed to be reading from. So again, document. Have your data flow diagram available as you go, and it's going to change, right? It's going to get updated as you identify issues and problems. You're going to find workarounds, and so this once again is not a static document. It is dynamic in nature. It's meant to breathe as the development carries forward through final deployment. And then once now I'm starting to build into my development phase. Right, this is where your first rounds of testing probably is at least case testing or manual review testing is going to come. Is the initial threat modeling, right? So where is the threat going to come from? Have we built resistance into the design? What is the risk? It is your first kind of like I said, official review of whether or not your as designed is meeting your as built. This can be extremely formal in execution, or it can be somewhat informal in execution, depending on the level of complexity that you're dealing with. However, the steps very much are the same, right? So, in a typical threat model, what am I going to identify or say that I need to ensure that I can check the box for? Identify the assets, right? What needs to be protected, what should be protected, what can go without some level of protection. What is my total attack surface? Once again, thinking about the attacker has everything, right? So am I taking account or an account of the entire attack surface? Plan for what could go wrong. Plan for what could go wrong and hope that it doesn't. And then select methodically, right, and then deliberately which risks you're willing to accept and which have to be mitigated. Oftentimes, this will not be delegated solely to you. There's the key stakeholders that you have to worry about, whether it be the organization, whether it be your primary employer, whether it just be you protecting your reputation. Which risk is acceptable? What's at a level of risk that I can accept versus which ones I have to address now? Okay, then identify how to perform one of the risk mediation and mitigation factors, whether I transfer it, reduce it, avoid it. Once I identify what I can do, um, that will play a role into the execution of how I do it. So if I'm willing to accept this handful, but these, okay, so this is a medium risk, and this is a high risk, and I need to transfer this risk elsewhere, or I need to just find a better way to do this. So I'm just gonna avoid that risk, just not do that, or put some other active mitigation in place by reducing it. And then finally, design protection, right? So design protection for each attack point within the attack surface, and then document it. Right, here's the anticipation vector, and from that attack vector, here's the inherent security mechanisms that I've put in place. It's here in this document, right? The model document itself, and then now we can move in to the next steps or the alternate steps of design deployment. Stride. So we take great strides. Uh, it's an easy way to remember spoof, tamper, reputation, information, denial, and elevation. So this is how we the classification scheme, if you will, for each exploit that we plan for and want to protect against. We take stride to prevent. Right. So, is there anything here that anyone has any question about? I think we've actually covered most all of these at this point. I'm more than willing to break into anyone that's just not understood. Is there one that just isn't understood here? Okay. All right. Well, I'll say silence is consent. You guys are awfully quiet this evening, but we've had a long day. So, but we'll keep moving until uh, we hit something that maybe interests you. So now, okay, so we've taken great stride to prevent every known possible attack across the attack surface from every vector imaginable. We've documented it thoroughly, so we should be good to go, right? So maybe not. So now, what do we need to keep in mind? Everything that we've dealt with thus far has been, primarily dealt with things that we can control. We can control the secure programming practices. We can ensure that we apply best business practice. So now we have to think about maybe some of the things we can't control, right? We call those zones, right? What zone is this going to come from? Is it a public or private or cabled connection zone? Okay, so essentially, and boil it down to for simplicity, right? That really all we're talking about is we're going to group together portions or threats that are similar, right? That are going to share commonality with others within the ecosystem, right? So if you're dealing with a threat from a public network like Starbucks, others are having to take that into, or should be taking that into account as well. Can you use or inherit some of the security protections and requirements from elsewhere that are dealing with the threat vector of the public network, vice a private network, right? So the risk is wholly different from public, where you have unknown bad actors, where you into a private network where now it's an insider job, right? Now it's disgruntled employees, right? It's a different look at the same problem. Someone unknown versus someone known. So as you consider these zones, right, you put it through the lab test, right? So who has access to the zone? Is it the public, or is it just this organization? Is it this organization and their vendors? What is the access level that I'm dealing with? What would be the possible motivation? Every attack has an underlying motivation. Some are very benign and innocuous and not sinister at all, but nonetheless, there's a motivation there for the attack within each zone. What is the target? right? Is the target a DOS attack, right? They're just trying to render the device unusable, or is the attack purely against the data? I don't want the device to be unusable. I need the device to be usable so it can continue to communicate with outside banking applications or networks. So I need to be careful not to bring down the services and hide myself within the architecture of the application or the device. So I'm targeting data. Right? So what is that specific target? Um, and then identify how each may get attacked. Is it going to get attacked from within? Is it going to be session hijacking? Is it going to be spoofing? How is this attack going to be carried out within each zone? Obviously, it's going to be a little different. Some of them will be extremely similar, dealing with, for instance, a public and a private network. Both of them being susceptible to hijacking, just at a different phase or a different level within the architecture. The overall business impact, right? Am I going to impact the reputation of the organization by having an application that is faulty or that is leaking data? What is that data worth? What's an organization's reputation worth? That should be foremost and paramount in your mind is the overall business impact of an application that has been compromised. And then finally, what remediations or what mitigations am I going to put in place? How am I going to reduce the possibility of attack or reduce the overall risk uh, that the attack will be successfully carried out? So once again, this is through each phase of design. As you design it and build it, you're going to have to continue to test in these predefined zones. Is this susceptible from inside or outside? Is it susceptible from application to application or device to device? So once you build protection in and around it, and you do it up front through each phase of the software development lifecycle, it's a lot easier and a lot less resource intensive, time, people, money to go back and fix it later after it's identified through more nefarious actions. So general guidelines, right? So what is the general guideline that we say that we need to follow, right? So obviously, number one on the hit list, look for the weak JavaScript. If Java presents itself as a number one risk factor, especially when it comes to the Android platform, for all the known and obvious reasons. So look for the weak JavaScript. Perform your own input validation. Make sure you have constrained fields protecting against SQL injection. So the first two take care of probably 60% of knowns, right? Whether it be cross-site scripting or SQL injecting. And then we get into what I consider what I call the outliers, like checking whether or not I'm storing sensitive data on external storage. Am I using good encryption? What external apps am I required or am I using to add or enhance functionality to mine? And then, am I testing it? Do I know that my app is only going to accept authentication or authorization from known entities to prevent session hijacking? Temporary memory, right? That is often overlooked in every phase within the ecosystem, not just within mobile devices. Just the attack vector or the possibility of accessing temporary memory within these mobile devices becomes heightened because of their mobility. Right? So if you're storing data, especially sensitive data and temporary memory or RAM, make sure that you're storing it there encrypted. right? Versus in the clear. How often do people turn off or purge their phones? I don't think I really remember the last time I did a hard reboot or rebooted my or restored my phone. As I know it's been at least a week or more. If I were to lose my phone, I shudder and think of all the sensitive data that would now be exposed if it were stored in temporary memory, RAM because I haven't rebooted it and purged purged it. So that's a general guideline, general checklist. It's not going to be the same for everyone. Once again, these are highlighting the key offenders, what's going to be seen as good testable information without throughout the examination. Those are very easy test questions to write. So those that's why I've highlighted those for your attention. Okay. So now we touched on a little bit designing through security. Uh, so those of us that like pictures, right? Nice pretty picture for you. Design through security. I'm taking a look at and mapping out. Okay, so this is happening at these levels, and here's where I have to build in a higher amount of data protection. Here, I'm relying on the data store of another to protect the data. Am I going to make explicit intent, or am I going to have broadcasts? Right? Obviously, the IPCs become extremely important here as apps begin to interact, react to the data stored in each other. It's kind of the overall idea or design behind some of the Android architectures that the apps can and is actually encouraged to share resources. So, if we're going to hold true to the platform and the freeness and the openness, and that lends itself to not over taxing or requiring too many resources for an app to run because you're going to share resources or share data with another. Make sure that you've built the design to meet the overall regulatory or statutory requirements for the application itself. I could go out and touch, for instance, you see this sales data server. Am I forcing it or requiring it to run over HTTPS versus HTTP? Okay, so that's what this is trying to show you is the design through security is I'm only going to allow communication and broadcast to the sales data server to go over port 443 versus port 80 to retrieve its data, right? And then I'm going to use an internal process right, to write from app to app or interdependency between each app. So then let me check the time. Time here. I think we're about there. I got a few more minutes before we take another break, so might as well keep working through. Classes, objects, methods, and fields. So these are common terms that we hear in what type of programming? Classes, objects, methods, and fields. Where would I normally hear these terms? Anyone can answer. Object oriented. There you go. Okay. Thanks, Bo. At least I know Bo's still with us. So yes, these are all attributed to object-oriented programming. This is not machine level programming. We're into calling states and objects and defining classes. Everything associated with object-oriented programming. Some of the benefits of object-oriented programming in a lot of ways becomes the security nightmare because you can make it very loose to begin calling and how you call into a field, how you define the classes becomes, like I said, somewhat of a security nightmare sometimes to kind of keep a hold of it because, once again, programmers are not taught up front to think about security. Their whole deal is to make it work. That's why we've employed them. So some of the best practices that we indicate with object oriented programming is that you should limit access to code elements, specifically by naming them final. Okay, declare objects and fields non-clonable. Is that a new term for anyone? Declare the field non-clonable. No, good. Okay. Okay, so yeah, that so close down the ability to once again to get a hook into that. Okay, so it's new to a couple people. Okay, all right. So the idea here, right, is if you declare an object or a field to be non-clonable, and once again you're dealing primarily within Java itself it doesn't lend itself, and it is as it indicates, right? It doesn't lend itself to duplication. So once I define it, once I name it, once I say that you are what you are, for instance, bicycle. Once I define the bicycle, uh, another app cannot come in and then re make a copy of it by using the same class element, right, or the same code element to confuse the IPC or the inter-programming call within the class that I defined. Once I name it final, it is what it is. It can never be duplicated by another service. It makes any other service reliant on me to for its functionality or structure. Okay. So that being said, that's why we say we make it final and then we make it non-clonable. Uh, there you have the specific piece of instruction that will identify that for that code element. So does that clear it up for you? Once I say you're a bicycle, you can only be a bicycle, and you can only ride my bicycle to get from here to the store. You can't use my structure to make one for yourself and then cause confusion through interdependency. Okay. Hopefully that cleared it up for you. Now that I'm closing the loop um, with interdependency and then making sure that it's only me that can do or carry out a set of instructions. Hold on. So it can't be subclass. Exactly. Exactly. Yeah, you once you define the class, uh, yes, it can no longer be as you wrote subclass. That is the idea. Once I define it, it is what it is, and nobody else can build anything like it and cause confusion. So yeah, that's exactly it. Okay. So now that the class is what it is, the element is what it is, I added some stability into it. I want to ensure the C of the triad, right? The confidentiality of the triad. So the way I do that is I try to render it impossible to serialize, right? So when we talk about serial data, right? Or think about it, common everyday terms, right? Serial killers, right? Repeatable, it repeats over and over and over until otherwise stopped, right? You don't want you don't want that possibility to exist. So what we do is we use the command write object. What that does is it prevents the attacker, excuse me, from inspecting the private fields, right? So it ensures that beginning part of security through obscurity, right? You can see it when you unpackage the entire code. However, when I use write object, I'm preventing further serialization of that object, or creep of that object. That is the C of the triad that we're talking about. Now, some objects have to be, or would rely on the ability to serialize themselves. But we do that with some level of specificity, right? So for serialized objects, to execute, say, read object, right? So what you're really doing is preventing you from losing control of the object state, right? So once again, we point back to the CIA triad: confidentiality, integrity, availability. That once I define an issue, right, that the object, right, with read object, I no longer will lose control of the state of that object, right? I'm maintaining the integrity of the object through a simple command. Now just think how these two simple, or seemingly simple ideas, right, of preventing serialization with write object, and for serialized objects, objects that must be serialized, to just define them with read object. How simple it is to maintain the balance between confidentiality and integrity, but often overlooked. Okay, so that hopefully is the crux of what you're taking away from this. Less the ideas behind, more the focus on just how simplistic it is in nature, that is going to protect the entire ecosystem as you move forward. Okay. So with that, now we've hit up against another break. So let's take a pause here, 10 minutes, and then we'll come back. We'll talk about exception handling, um, and how to deal with those. All right.
All right, we all make it back. Paul's funny. He shamed us all. Um, but I would almost indicate don't beat yourself up too desperately over. Remember, I said at the beginning, right? Best business practice changes over time. It just kind of is what it is. But that's funny, Paul. Okay, so all right, so now let's deal with some exception handling. What is the best case or worst case scenario, or how should we address exception handling throughout secure practices? Excuse me, I went down the wrong pipe. Simply put, exceptions are nothing more than unexpected problems. Right, something's running, and you need to figure out how are you going to prepare for the unexpected. The bad part is, right, we've tried through the best planning and due diligence to be prepared, but ultimately Murphy's law will always come back to get us. We didn't plan for everything. It's not possible to plan for everything. So the best we can do is try to identify how we are going to fix it. Ultimately, why are exceptions an issue? The exception itself is not the issue. However, the possibility to expose holes, right, in the underlying architecture is the problem with exceptions. So, how we handle them becomes a little more delicate. So, we try to handle exceptions properly. With what is indicated as the try block, right? So you wrap the potential problem in a try block, through maybe some. I don't know if you guys ever do write Visual Basic or anything like that. I've always kind of associated the try block with the else or if loop, right? So you run into an issue, it hits a roadblock, you issue a try, and then if continues to be unsuccessful, then you end it with a catch, right? So you're going to try to execute. Absent the try, I will catch. What the catch is doing is it defines the exception. Um, that was failed to execute by the try, and then it will output an error message. Nope, can't do that. Whatever your error message indicates, it could be, and it's really kind of a definable field. However, it's important to understand that you shouldn't ignore. The exceptions, right? Exceptions shouldn't be ignored with an empty catch. You should make it uh, write out, even if it is only writing out into the error log itself and not through the visual user interface. Uh, what happened when it tried to execute and failed? Right, what caused the instability, so you can go back and identify the issue and then address and fix the issue. Okay, so that's the key here. Um, Reflection invalidates the prevention of serializing. That's true. That's true, Paul. The prevention of serializing objects is somewhat. Well, yeah, I would indicate somewhat of a new approach to things. So exactly. Well, then the job is done. You've maybe took a nugget of learning out of tonight's instruction. So. Okay, so that's how we deal with exceptions or dealing with the inevitable unknown. We issue a try, and then we issue a catch, and then force it to write out to the error log and just not to ignore it. Okay, so now let's move into some of the building blocks, if you will, the elemental phases of the architectures. Right, we start with packages. Right, and so first we define the package. Right, as packages are bundled sets of related code elements. They make up a package uh, by identifying or wrapping into the package what you're hoping or should be preventing is naming conflicts. Right, so this goes back again to the whole idea of subclasses and serializing. Uh, the package is all interrelated code elements, all maintaining consistency and naming, and then of course maintaining the CIA triad. And you want to define the package as private. So defining the package as private again indicates that you are going to obscure or slow down or attempt to prevent identification throughout the scheme as you identify through the class objects elements, and other elemental variables. Okay. So once I identify it as private, it is going to prevent untrusted classes from accessing your package, right? So think about the things that come from, for instance, untrusted sources. You might have to call out to, for instance, I don't know, maybe an RSS feed. Right, so that's going to obviously come from an untrusted source, being the internet. You should not allow anything from that untrusted source to come in and access your package. That's why you're defining it as private, right? So nothing else is going to read into or through it. So as we build out the packages, you build out obviously in interdependencies. So if package is public, it's possible to expose methods. Exactly. Yeah. Okay. So there you go, Matt. So yes, if I don't define it as private, essentially I haven't obscured uh, my classes to the point where now an external source, whether it be for the good or the bad, I'm exposing the external to the external, whether it be another application or what have you, into my objects and my object variables. Once again, if I didn't prevent cloning, they'll be able to now read into the package, and it begins to proliferate itself. And remember, I said this is all a watershed event. Once one happens, it's very hard to get ahead of it without a lot of resource intensive work finding where these injection points were. So good. That's good, Matt. Thank you. So yes, now I've defined my package. I've kept it private. I'm ensuring that nothing else is reading into the structure. So now everything is reliant on me. However, there are interdependencies that I'm going to have to deal with, primarily and foremost the static libraries, right? So static libraries are nothing. They're like code element libraries that are compiled within the app itself, right? So it calls for efficiency. Obviously, right? If my app doesn't have to go out and use other services or instances, reduces the possibility of interdependent issues. Like we talk. I think I got a small show of hands during Monday's class. How many people have dealt with Linux and Linux programming or Linux administration? It can be frustrating, right, to build out a Linux system and realize that you have the wrong lib file. You have to go out and go get another C library or whatever. Yes, it limits the dependency issues that you have. Obviously, faster performance because it's all compiled within the app itself. However, the issue now that you're going to have to address is anytime you issue a security update, right, that points to the static library, that means your app is now going to have to recompile. Okay, so you need to determine through the balance of the CIA, confidentiality, integrity, availability is faster performance and more reliable, right? So I'm bringing up availability. Uh, is the trade-off of needing to recompile at every update of the static library, uh, the need of that outweighing the other. Okay, and so uh, that in and of itself leaves the app vulnerable, right? Anytime you have to tear down and then recompile and build, you have opened another attack vector, right? Then you have the obvious issues that you're going to have to deal with is where some apps are extremely quick and easy to update. Now, if you're having to recompile the app, uh, basically recompile from source, the update is going to take a lot longer time to execute. Maybe they can't do an over-the-air update, for instance, and maybe they're going to have to be plugged in and physically connected to a computer to perform an update, and that might cause issue with some users, right? So that is the give and take, right? When you start using static libraries versus the universals. Okay, now let's discuss a little bit the exceptions that you've caught, the logs that they're filling up, and the memory that it's being housed in. So we discussed right briefly that exceptions, while not nefarious in their own right, they can expose underlying security issues. Um, for instance, out of memory. Right, so out of memory, just throwing the exception out of memory is a forced shutdown action. Right, it's kind of a self-preservation action. Uh, However, it, the system or the object or the device, with, without going through the try and catch, if it's just allowed to receive the out of memory command, it will just force shut down the object or force shut down the device. um, that is nothing more than a DOS state, right? You're denying service to the end user. So that's once again why we always want to use the try and catch statements. Okay. It's important to remember that logs are shared. They are not inherently private. Right. So the ability of other applications to read into the log is there, right? It kind of has to be there. It's how the basic architecture works. Even the temp logs can be scanned into by other applications. So why would another application want to read the temp logs? Uh, for no other reason than to offload data about your error exemption, your exemption handling, to find the weakness or find the hole through your good practice. Again, right? You issued the try, you issued the catch, you wrote to the error log, and now another application can read into that log because by nature the logs are shared. So the error log and what you write to it should be obvious to you, um, for you to be able to troubleshoot, but it shouldn't give away too much information. It shouldn't draw a complete picture, maybe sketch the outline of an issue that's happening. So that's the takeaway there. The understanding that the logs are shared, that other apps can read into the log. So what you write in the exemption or the error handling, you don't want to be too descript to give away too much information. Okay. So when we deal with again with the logs and what's being housed and what's being dumped, of course you can't get away from that conversation without discussing what happens when you're dumping to memory, right? So one of the core components, for instance, of the Linux operating system is every time it reaches a failure, it immediately writes, right? It writes a panic, so you can go back and identify what just happened. So essentially, it's doing a mass memory dump before it goes and loses its mind. Knowing that Android devices are built on the Linux kernel, that's one of the inherent protections. That is a possibility that you have to be aware of. right? That through a DOS attack, you can be dumping sensitive memory, or I'm sorry, sensitive information into memory, such as stored passwords, right? So we discuss, okay, how do we store our passwords? Um, do we store our passwords through the character array, or do we do it with string object identifiers, right? The indication really is to store in the character array versus the string object identifier, because string objects are one of the core components of really troubleshooting what happened in the panic that caused the system failure, where the character array is not. Right, it is nothing more than a static identifier. It wouldn't or shouldn't, unless otherwise compelled, be dumped directly into memory. So and then then obviously you see highlighted the last piece to identify is wiping the passwords from memory. The value can be set at zero using that character array, and that's going to wipe the password from the memory, right? So it's going to, during the force dump, it's just going to zeroize it out of memory. So this one usually causes discussion, um, because it's probably something that everyone knows to do. However, very few people do it. Right. When we start talking about naming conventions, consistency would be the overall takeaway. It's not necessarily a uh, steadfast, you're causing a security issue type subject. What it's doing is it's taking away complexity and thought, right? So using correct naming conventions makes the code easier to work with and less prone to vulnerability, right? If everyone knows that this is the standard, uh, and it maintains the standard, then at the end of the day, when code review comes along, or maybe you're using a case tool, you're not chasing down a bunch of false positives because the naming convention doesn't meet the overall static or best business standard. Okay, so does that make sense to everyone? I mean, I don't know. You guys might have better practices than some of the um, programmers that I work with, but sometimes reading their code is just a nightmare, right? Because they've mixed everything. They've mixed, essentially. It looks to me like they're mixing the cases, and I can't tell where it's going from left and right anymore. But I'm sure you guys don't do that, right? Ha! Yeah. Well, all right. Well, so we try, and that's all. That's really all you can hope for. Like I said, it's not a security hole in itself. It's just it makes identification of potential weakness a lot easier when there's, just standard convention doing across the board. Everyone except for Matt. Ah, well, there you go. It makes sense. Okay. Um, so, obviously, right, you want to make your identifiers meaningful. Uh, Now that once again is open, I think open for discussion. First thing we said was we want to practice security through obscurity. So meaningful does not necessarily mean overly descript. Right, but however, someone should also understand what you mean when you provide the identifier. If you're going to make it so obscure that now it can't be followed, then once again, you're opening the possibility for human error, and that seems to be uh, the catch-all, the carry-all. Honestly, it really, at this point, I would almost indicate it doesn't matter as long as everybody on the team knows what the convention is, knows what the identifiers mean, and then you're working off a uniform standard going forward. Okay, so that's really all I would give you to that. um, Code isolation. So code isolation, it kind of gets interesting. I think, right. So how do you isolate your code, right? The unrelated code from the main application. Um, and why do I even want to do it? If it's unrelated, why in the world am I packaging it in the first place? Right. So this all comes to the interoperability standard. Right, so you're always going to have to deal with unrelated code, and we see here again an example of an RSS feed. That's not your code, right? It's not your code to manage or maintain or be aware of the carrying, feeding, and maintenance within the security requirements. So what we indicate is that you practice code isolation. You don't let anything from an outside source. You treat it all as untrusted, and you isolate it from your main service or your main application, right? You separate from the untrusted source, and that way you don't have to rely on somebody else's bad action or inaction for your overall security requirements, right? You make it their requirement rather than yours. Okay, so how many Java programmers do I have in this group of seven or eight? Uh, any? Yep. So Matt's a Java guy. I think. Okay, so most of us has used it. So good. I think what I'd like to know, and anytime I get a room full of Java programmers, because Java absolutely, I know enough. Obviously, I know enough to be dangerous with it. I quick, dirty, simple, get the job done kind of guy. Right? I write a security script or something like that. Um, is anything here that you see indicated as the guidelines for writing secure code? Does it match what you currently do, or is there anything that just doesn't make sense to you, or wow, I never even thought about it that way? Looks pretty okay. Good. Good. Okay. Well, and like I said, that's always what I want. What I want to know. Most importantly, to keep consistency from class to class, and to make sure that because understand that certification tests are just that, they're standardized tests, and it takes a while. Usually most of them are about a year or more outdated, because that's how long it takes to get a good bank of test questions out of the beta pool. uh, Especially in technology, things move faster than obviously the certifications can keep up with. But I like to think that these are pretty solid, just simple, bedrock best practice kind of stuff that should remain kind of constant, regardless of how things begin to move. Um, while using native code is negative for security. Okay. Um, so the hard part with native code, and that is, and you see I didn't necessarily highlight that because it is one of those what I would consider it's there are too many right answers to be right. Native code uh, in its raw form, right, from the raw SDK, um, is supposed to be inherently secure, right? If you don't stray from it, you can. It's supposed to be fairly secure and stable. The the thought pattern really becomes that the native code, because it is so raw and because it is so openly and publicly accessible, that because it takes so long between updates, if you are relying on native code for overall security, that you are going to be overlooking or bypassing in some cases wholeheartedly some of the inherent flaws or vulnerability that's associated with it. But once again, that is one of those. There are too many right answers to be right, so it makes it very difficult to test against, and that's why I didn't highlight it here. It's just a static answer, right? For the 90 minutes that you're in that test room, you kind of have to forget what you know. And go with what CompTIA wants you to basically believe, which is avoid using the raw native code because it lends to insecure practice. Unfortunately, that's really kind of the best non-answer I can give you on that, because I'm not even sure that I wholeheartedly agree that to avoid native code. I think it's impossible to wholeheartedly avoid it, but you need to take into consideration the some of the vulnerabilities with it. Right? Does that answer your question, Paul? Good. Okay. And so it's going to carry. So we carry on, right? Some more once again guidelines or best practice that we've already dealt with. I think most of these, once again, are kind of commonplace, right? Yeah, they more or less kind of go without saying. Um, Now the last one I thought I highlighted, but I guess I missed that one. Declare all sanity tests, static inline, right? So that kind of to me is just one of those. Yeah, that makes perfect sense, right? Essentially, does it pass the laugh test? Do I have a predictable result from a predictable input? uh, is there stability in the chaos, and once I've assured that, I begin to move at a more reliable pace or vector. Okay, so that closes section 3. um, there is not a lab associated with section 3, so don't worry about that. Just once again, the reflective questions, things to think about. But this, we're all grown adults and we have lives outside of the 3 hours we get to spend together. So it's not like I'm going to expect an essay on this at all. Okay, let me check our time. We're a little bit ahead, but let's go ahead and take a short pause here while I switch out the screens, and we'll come back in let's say 10 minutes. Okay. All right. All right. So we all make it back. It looks like most of us can never really tell. The icon says that it's idle, but may not necessarily be idle. It just might be you haven't moved your mouse in a while. So I'm just going to assume that we all made it back. Okay. So I switched displays a little bit here. Are you guys still seeing the slides in full screen at all? No. Okay. All right. So I was kind of afraid of that. So let me go ahead and switch the display back. I kind of thought that maybe it would help, but maybe it didn't. Mm, let's try this. Nope. Okay. All right. Well, once again, I thought maybe it would do right for me, but I guess not. Okay. All right. So now we're going to, and that should have switched it back for you to the full screen. If it didn't, okay, good. All right. So now we'll move into module four. Module four deals with accessing local processes and devices securely. So it's one thing to access the process. It's another thing to do it in a secure manner with proper error handling and exception handling and what have you. So not to be thought of or confused as synonymous in nature. It's very easy to access the process. However, it gets a lot more difficult when you start dealing with how am I going to access the process and do it in a more secure or up manner. And that's where most everything begins to fall apart. Oh, that's not what I wanted to happen. Um, current slide. Okay, now we should be back on the right page again. Okay, so how do we do this? How do we do it in a secure manner? How do we make sure you're seeing both screens at this point? Well, all right, so only one. That's good. There we go. How do we make sure that we do this in a more secure manner and make sure that we're handling proper error handling throughout the entire coding processes, right? So we have to make sure that we're incorporating security into the entire development process, from the initial design phase all the way through the software development lifecycle, all the way through final disposition. Sometimes disposition can be the weakness in and of itself, right? Because especially nowadays, and especially within the open source community, just because you're done or you have sunset an app, someone might like what you did. And most code is freely accessible. So they begin taking from what you are now sunsetting, repackage it, remarket it, and then send it out. Maybe they don't have as noble intent as you do, right? So all the way through sunsetting an application or sunsetting a software project is almost as important as the initial requirements phase, right? How are we going to ensure that we sunset our processes? Primarily, what we're going to be dealing with here is through the design phase of it, right? How am I calling on certain processes? How am I making sure that I'm not dumping flat text or plain text into memory where it can be accessed elsewhere, or into the error logs or into any log without encryption. So these are the steps that we're going to start dealing with when we start talking about how we're going to handle some of these process threads. We start with interprocess communication, right, or IPCs. Interprocess communication, once again, is kind of how the Android platform was born. How to do it a little more efficiently, better. Let applications use each other for in state productivity. Right, the Android devices are inherently highly connected. Right, think of all the different interfaces that you're dealing with, whether it be uh, the cellular network itself, Bluetooth, Wi-Fi, NFC. Right, think of all the different ways that the devices are connected, and you see the multitude of attack vectors that ultimately you have to deal with to ensure secure practices. keeping in mind once again that, for instance, logs are readable by other applications, right? It's part of that, inside or inward faced connectivity. Not only is it a big, wide, open network from the device out, but just within the device itself, it is highly connected where apps are using each other for end state. Okay, so to understand how all of these things kind of work, yes, they are each supposed to be within their own sandbox. They shouldn't be jumping out or able to get out of their own sandbox to perform action. Uh, but the interconnection, or I'm sorry, the interprocess communication is the exception to the rule, right? That's what it is. The built-in process that allows for the sandboxed activity to get out. Of its sandbox, use another service or use another mode or method to perform what it inherently was designed to do. And it can do that in a multitude of ways, depending on what the overall end state is for the design. So, keeping in mind what we're talking about here, mostly is user trust, right? The user is going to put a level of trust in you, the designer, that the IPC is being used strategically. That it's not just a catch-all because you were, for instance, too lazy to write a service or a system to and of itself. Um, yeah, if you guys will excuse me just 1 second, it sounds like something is going insane outside of my front door. I'll be right back. Ah, okay. I apologize, guys. That I have a bulldog that anytime someone comes to the front door, he has a tendency to want to try to jump through the door for some reason. Um, However, he'll lick you to death before he does anything else. So, but he causes more damage to the door than is warranted sometimes. Okay, I'm sorry. So yes, when we deal with inter process communication, once again we're impeding on user trust. So the user is trusting that we're using it strategically and sparingly to ensure that the activity that we have deemed necessary, or the process, or the call, or the activity that is necessary to execute the end state is being done well and with good structure. So, as we talk through the inner process communication, there are certain definitions that we need to understand, components, if you will, activities, service, content providers, and broadcast receivers. Right, so these are the basic components that any one application or series of applications are going to need to use the IPCs for. Okay, so the activity, what does the activity do? The activity provides a single screen for the user interface. That is defined as the activity itself. It enables the users to perform a specific task, whatever that specific task is at hand. The service, however, has no user interface, right? It runs in the background. It may be performing a service like downloading or decompressing, right? So that is what the service, the background service, is doing. The content provider, it kind of is as it sounds, uh, makes the database available, right, to other applications. So the app itself can be the content provider, or it can be calling on another content provider, right? We would, we would sometimes refer to that for example, is the broadcast receiver, right? Again, the broadcast receiver, there's no user interface. It happens behind the scenes. And as you can imagine, anything that happens in the dark, is kind of hard to protect against, especially from the user experience. But it carries out a very important service, right? It essentially is relaying messages to one activity or service or another as to what action to carry out next. So the user doesn't see it, he sees or she sees the resultant of it. Okay. So it's important to understand those core components: activity, services, content providers, and broadcast receivers, because they're going to play kind of integral parts into the continued discussion. So communicating across the application boundaries, right? So now we're breaking out of the sandbox. We're breaking out of the protected zone, if you will. So the way that we identify within the Android platform to break out of the sandbox, to break out of the protected zone, it's in the app manifest. Okay, the app manifest essentially, what's the good word that I'm looking for here? Defines, right? It defines the individual or the various types of the app components that are flagged for export, right, or flagged for use by another activity or service, right? You will identify that within the app manifest. um, or it will define communication even within the same app, right? But it's important to understand that these exported components can also receive messages from an outside app, right? So we're going to get into the importance of defining and putting true and definite parameters within the app manifest, because not only is it capable of export, but it is going to receive information from another app. So when we talk about, how do we begin defining the manifest itself, and how do we start, locking in boundary, we do that with intents, right? We state definite intent. We try to stay away from what is often referred to as fuzzy intent, or a sticky broadcast, right? What does the intent do? A variety or varied things, right? It can start an activity, right? It can start an activity either without receiving a result or with receiving a result. It can send a message, right, to all other broadcast receivers, right? So it kind of is the foot on the pedal, if you will, right? Going back to the bicycle. I'm going to define that bicycle, and then I got to figure out how to put that bicycle in motion. We do that within the Android platform with intents. Okay, so that's the foot on the pedal. You have three options with this. Three ways to send out the broadcast of your intent: normal, ordered, or sticky. So the normal broadcast, it kind of is as it sounds, right? It's a normal broadcast, send out to all registered receivers, right? It goes out all at once, and then it disappears, right? So kind of fire and forget, right? That's the way to think of the normal broadcast. An ordered broadcast, however, it is delivered to one receiver in sequence, right? So it's going to shoot out to receiver A, receiver B, receiver C. It will not go to receiver B until receiver A has been sent the intent. right? So it's kind of a cause and effect action that you're going to deal with when you start dealing with ordered broadcasts. And then we get to a sticky broadcast, right? So a sticky broadcast or extreme or dangerous at heart and in nature, because the broadcast itself remains accessible even after it's been delivered. Okay, so it's not a fire forget. It's not doing it in a sequential order. It's firing and allowing it to remain to be called on repeatedly. So this is where we get to, okay, depending on what type of intent, or I'm sorry, what type of broadcast I'm going to use, I need to define my intent, right? Do I use an explicit intent or an implicit intent? And simply, I mean, if this now becomes kind of an exercise in more in comprehension than it is anything else, defining explicit versus implicit or implied, right? Explicit intent directly specifies to the class to which the request will be sent. So once again, we see the importance of defining the class and making the class static or real, because once I send out that broadcast, whether it be normal or ordered, and then use explicit intent, it will only go to a predefined, authorized class for carried out or intended execution, versus implicit, right? Implicit intent specifically, it calls in specifically to the action that needs to be carried out, but not specifically which class. Okay, so it's like being told you have to go to the store. Okay, so I have to go to the store. It's not defining for me which class must carry out going to the store. So it can be going to the store on my bicycle. It can be walking to the store. It can be driving to the school. It is not explicit in its intent. The only thing that is looking for is a resultant action, right? So it's not going to lock it in to a class. All it wants to receive is that you understand your direction at this point is go to the store. Okay, make sense? Okay, so uh, obviously, I think that it lends to, you're probably picturing all the issues that come when you start dealing with IPCs. Because you're breaking out of sandboxes, you're putting something in motion, right? You believe in physics, an object in motion, wants to stay in motion until met with equal and opposite force. So you're starting a process that you can, unless quickly defined and locked in, lead to other processes that are unintended. So, how do we think about the IPCs? What do they look like? I find it easiest to describe the IPC and what it's doing, the same as I describe when I do networking classes in Windows architecture, as RPCs, right? Remote procedure calls. That's really all it is. IPCs, it's a network within this boundary we call a device, a phone or a tablet. It's the network inside. If I could, boil down your office building with all the routers and switches and servers and everything that is interdependent on each other, shove it into a phone, it's the same thing, right? So within this mobile platform, we call it, IPC within a network architecture, Active Directory structure, Windows architecture, we would call it RPCs or remote procedure calls. Okay, it's causing an action downrange for something I need to happen up front. Okay, is that is that clear for you? Between IPC and RPC, can you picture the huge network all shoved into a mobile device? Right, it kind of makes it, I think, maybe a little bit easier to think of big things and big pictures than it is little small things that I've never really seen per se. With the IPCs, what inherently is the risk, right? Anytime you break out of a controlled environment to an uncontrolled environment, I have raised the attack vector. I have raised the exposure factor. Essentially, I'm raising the likelihood of exploit of vulnerability. So we look at what truly is at risk, the data itself is at risk, and then the usefulness of the device is at risk. Whenever I break out of a controlled environment, I'm going to start leaking data either intentionally or unintentionally, and I gotta plan for that. So understanding that I'm either A, going to cause denial of service, or B, I'm going to cause data leakage, then begins to show me how I need to plan for and build protection around. Once I understand that any app can send or receive an intent, any app can start pedaling the bicycle. It's just up to me to make sure that the apps basically follow the rules of the road. Okay. So that's really what I'm trying to get at. Trying to get at there. Uh, break it down into what I would almost indicate as an oversimplistic fashion, but it lends to the paranoia that I enjoy. Uh, the factors that affect the IPC security. Okay, so when the intent receiver has been exported equals more vulnerable. Um, it leaves a protected zone, right? The receiver has been protected by some permission or another, right? Now I'm leaving that zone, so now it's leaving my protection equals more vulnerable. Um, the permission levels begin to adjust, right, from platform to platform. When the Android goes from three to four, one to two, you're going to have to deal with different inheritance that some things were able or implied in one version, and now they have to be defined in another. Uh, that level of complexity begins to indicate um, now I'm making that protection level more vulnerable. And then finally, right, whether the receivers targeted by the intent are implicit or explicit. If I just say go to the store and leave it up to you, I'm leaving a lot of room for error, right? I mean, I might know that that I live in a high traffic area, and three pedestrians last week were hit by vehicles. So I implore you to get in your car and go to the store, vice walk and go to the store. I'm trying to decrease the possibility of export or exploit, right? So that's what I'm trying to define for you with implicit and explicit direction. Excuse me. So um, let's deal with the permission levels first, and how to deal with permission and vice intent, vice. How am I going to carry out what should be a unified action across two different applications and make it seamless, or as seamless as possible, right? So if my goal, for instance, is the stated goal is to protect the customer's app data, right, from unauthorized users, right? Someone that does not have explicit permission to access the application. How am I going to do that? So one way I can do that is to enforce user login into the app. Okay, so I can have my phone sitting on the table and require some sort of login to access the phone, or maybe I'm just one of those people that I don't have a password or whatever on my phone, and we'll talk about that kind of person later. But however, the application itself, for me to launch the banking application, I have to put in a 4-digit PIN. Okay, so I'm going to protect the data that application houses by an additional security measure that we're going to call a user login. I can go further, right, to protect the data, that even after I require a user login, that I also employ encryption, right, either at rest or in transit, right? So now I will use a second layer of protection, because first I'm protecting against local access. But as soon as the device begins to transmit, it doesn't do me any good. Uh, the, the interface requires a 4-digit PIN if I'm going to start broadcasting everything over HTTP, right? So does that make sense? Right. So I need to, if the goal is the protection of the data from unauthorized users does not necessarily equal physical possession. Right, unauthorized users of data are going to try to intercept data by any means necessary. Physical possession is not always the end state. Okay, don't think in those sort of um, static parameters. Um, define exported. No, Matt, I didn't, and we're going to get to that exported definition, and see how it kind of fits together here shortly. I just wanted to throw out there that yes, you're going to export, and then we'll deal with how to protect against that export. Okay, just understand that is kind of what's being pushed through the manifest. Okay. Okay, so now that I have the basic design in mind, I need some sort of user interface that is going to require a 4-digit PIN, and then even after the 4-digit PIN, I have to open a secure communications channel. So now I should have met all customer protection requirements for unauthorized access to the data. So, how do I begin to define this? Well, I'll begin to define it through custom permission sets. Right, I'm going to customize kind of in a language that only the two apps understand. So I kind of akin it to my parents when I was young. I guess maybe 5 or 6 or 7 years old. They would speak Pig Latin, and only the two of them understood it. And I at 6 or 7, right, you barely have a grasp of English. So I didn't understand what they were saying, although they were speaking in plain English right in front of me. But I could not interject into that data stream. Okay. Anyone else have parents that spoke Pig Latin in front of them, and it baffled you? Am I the only one that lived in an insane household like that? Okay, so either I was the only one that lived in an insane household, or you guys just want to make me feel insane. Okay. Um, Oh, they spelled it out. Okay, well, yeah, yeah, that makes sense too, right? 7, 8 years old, you're just getting the 4 letter words, right? 4 or 5 letter words, so they'll spell out the big words on you. We found out at a very early age that that didn't work on my little girl. She was able to sound out words, so we had to go beyond spelling out. Um, They spelled it out, no Pig Latin. Okay, so I was the only one that lived with the insanity of Pig Latin. I was that makes me feel better. Thanks, Paul. I appreciate it. Somebody could have just lied to me, and I would make me feel better about myself. Okay, so um, thanks. So yes. So how do we define this? How do we define the interaction between applications? Between, for instance, it's showing you the monthly sales app, which has one user interface, and then the customer app, which is showing me that Bob is a customer and his company is blah. Okay, so I'm going to define it in a custom permission set so that only those two apps can speak to each other. Right. Now this is important because the default setting for the protection level or the interaction, if you will, is defaulted to normal, and normal it kind of is as it sounds, right? It provides the least amount of protection to app interaction, so that would indicate that any app can call on using the IPC any other app's data, and if it's set to normal, they're all speaking the same language, they're all speaking Pig Latin, for instance, or they're all spelling out the big words, so it will begin to interact and exchange data from its protected zones. So what we want to do is we want to move it out of its default setting of normal and move it to a protection level indicated as high, um, or define an encryption parameter. Uh, Oftentimes, we'll see that set or indicated as true. Okay, or signature required. Okay, kind of like the UPS guy coming to your door, right? He's not going to leave the package until you sign for it. Okay, so that is how we define the parameter, the custom permission set we see here, right? For to read the company contacts, I am requiring a protection level of signature. That indicates that unless you have the matching signature or the matching key, if you you will not be permitted to read the company contact. And then I'm going to assign the parameter in which that is assigned. And here you see I've highlighted for you. Let's see if I can draw draw it red. Yeah, red's good. Highlighted true. Oh, oops, back up. Highlighted true for you. So yes, once you have provided the signature, the matching signature, yes, I will then export that data to your data store. Okay, so that is how we define a custom permission set. Take it out of its default setting of normal, raise its protection profile. We do that by indicating the signature required, or the UPS guy coming to the front door as signature required, and only then will I now export the data to you. Okay, so here are your four different protection levels. As we indicated, normal is the default value. Anyone that says hi, you're going to say hi back. Dangerous is granted by the user during installation. So that's one that kind of matches. Um, uh, the definition, right? When you do that first install, the permission level is set to dangerous, because now we're deciding exactly what level of access or ID, authn, or author we're going to give you to the device. the developer signatures must match. If they do not, they'll drop the request and say no, no, thank you. Or the highest protection or most protection, signature or permission. Meets the signature requirement, or if the app is installed in the system's application folder, right, which is a protected zone within the architecture. So if it's installed in the applications folder, um, then it will at that point become trusted based on the permission level that you allowed at install. Okay, does that make sense? Okay, so I think we are about about at that space. We're going to take a 10-minute break. We're going to walk through some of the vulnerabilities and threats, be it broadcast theft or session hijacking. And that should take us up right about to the end. All right, so stop here or pause here or take a quick break, and I'll see you in 10 minutes. All right. Did did we all make it back? I think I might be a little fast, but if we're all back, we can go ahead and get started. Um, don't have a whole lot farther to go. Um, okay. Okay. Good. Uh, that's funny. Okay. Um, okay. So let's walk through, I guess, a little more of the definitions or how we handle uh, crossing data, or, cross pollination, I guess, if you will, of data from left to right or from app A to app B. We talked through first, you establish the intent, you make it explicit or implicit. Um, and then you handle it. How do we deal with the most common threats to these actions? The discussion centers around whether you're going to have to deal with broadcast theft, activity hijacking, service hijacking, intent spoofing, or what's referred to as the confused deputy. Okay, so first, when we deal with a broadcast theft, what are we really dealing with, right? The intent is implicit in nature, which means I didn't make an explicit call into the class, and it's not protected by the signature. Or indicating the signature or the protection level of signature or signature or system, right? Essentially, I left it an implicit action left in its default state. So now, effectively, I'm sending out a public broadcast that calls for action. That would be highly susceptible to broadcast theft. Now, when we think of broadcast theft, remember, we're talking inside the device. We're talking from app A to app B. Okay, so just think that you have a malicious app or an app whose target is only to target your data or the data that's being processed. You send out a public broadcast. That means that it is open to be read, tampered with, or stolen. Right, so that's what we're dealing with when we're dealing with broadcast theft. The sender or user has no indication that the intent was intercepted. Uh, right, you broadcast it out publicly, and lo and behold, the public heard it. Right, it's kind of like leaving your Wi-Fi open, and then being mad when someone like your neighbor or whatever starts using your internet. Right, we're talking the same thing. Broadcast theft. There's a bevy of ways to protect against it. Most importantly, raising the protection requirements to either signature or signature system. Um, or it has been commonly used to use what's known as a sticky broadcast. Now, the problem with the sticky broadcast is it cannot be protected by the permissions, right? So if I indicate that it's a sticky broadcast, one logic would say, okay, it's now I've brought it down, for instance, from a public broadcast, but by using sticky, you cannot offer additional protections like signature, for instance. An ordered broadcast, however, is also susceptible to a denial of service or data injection, right? Just think of how data injection happens. We indicate that what's going on is the attacker or the attack vector is in between the time of use and the time, or the time of check and the time of use. Since now we know that an ordered broadcast happens in sequence, all I got to do is interject into that sequence to now hijack the broadcast, right? So once I hijack the broadcast, I just simply put it into an unstable state. Once I make sure you've entered into an unstable state, I have achieved my goal through that attack, which is a denial of service, and the app shuts down. Right, it caught something that it wasn't expecting. I interject into the sequence. It never gets the next logical or the expected sequence, and the app crashes. Okay, so those are the issues that we're confronted with when it comes to broadcast hijacking, vice intent hijacking. Okay, somewhat different and a little more elegant in execution. Intent hijacking. What's happening is the bad app, right? App B is intercepting the intent for the activity, right? So the intent is I send a call action to launch the browser. um, and unless I implicitly identify and require user interaction, I will inject my intent versus the expected intent of A, launch the browser, and I will have it perform my intent. Either before or after the action. Most often, you will see it performed after the action so that the user gets the expected result. And then I give it another intent or an accompanying intent. So launch the browser and then broadcast to this service, right? So the user doesn't necessarily see that the intent was hijacked because they got the expected result. What they didn't see was the unexpected result of redirection of data flow or copy of data flow to an unintended direction. So we would define that as intent hijacking. Okay. Here's another illustration, if you will, of intent hijacking. The goal is not is to operate in an obscure manner. So I don't want to interrupt the fact that you launched the browser. However, I want to inject my intent inside it so that yes, I launch your browser, but also I make a copy of the data that you are performing for later use. So uh, when we deal with intent hijacking, it, it is a very close, if not first cousin of activity hijacking. They're near the same. I have to almost perform one before I perform the other. We've all seen this screen, right? If we have an Android device, I open or I press a link to open a document, and it says, "Okay, so what do you want me to open this with? Adobe Reader or Chrome or Firewall or Firefox or what have you?" Um, the idea here again. Is to allow the user to perform the intended activity. However, and it's kind of closed its hole a little bit with the later releases, but the earlier releases were much more susceptible. Um, it forces the user right to select. I want to use this just once. Every time I open this type of document, you always use Adobe Reader, um, or only this time I'm going to use Adobe Reader. Allow me to make another selection next time I make this type of selection, right? So in activity hijacking, the malicious activity registers to receive the implicit intent uh, normally serviced by other apps, right? But the malicious activity might immediately launch that normal activity, uh, so the user isn't alerted that another service is kicked off behind it. Generally, it's extremely hard kind of to catch. Um, Unless you have another app that, for instance, monitors your system resources, and if you're one of those people that says, okay, here's what my normal baseline looks like, um, and now all of a sudden, I open Adobe Reader and everything tacks out, right? That would be the way to identify whether or not the activity choice, right, or the intent hijack is happening on the backside. Service hijacking it kind of is as it sounds. It's another form of intent hijacking, except once again extremely hard to detect, um, because it happens behind the scenes. Right, there's no user interface to it. There's no select this. There's no prompt to do every time. Services are kicked off on a constant basis on the backside of almost every action that we perform. So if I don't give you implicit intent, or I'm sorry, explicit intent, and leave it up to implicit or implied, then at that point, if you don't tell me how to do it, I will make the selection how to do it, and that's what makes you susceptible to the service hijacking. And all you said was get it done, so I'm going to choose the service to do for you, and now it might not necessarily be the service that you intended, but you don't see it because it happened on the backside of things. Okay, so that's service hijacking. Intent spoofing. So intent hijacking, right? Again, occurs when a malicious component pretends to be friendly, right? To be a friendly broadcast receiver. Hey, I'm your pal. I got this. I can do this for you. Conversely, when we deal with an intent spoofing, um, what's happening is the component on the receiving end is basically tricked, right? It thinks it's talking to a friendly, but because I didn't define my parameters, I left it open to implied versus explicit. I think this is where I'm going to go. So he looks like he has a nice face. I did no idea. I shouldn't take candy from the guy in the van, kind of thing, right? So there is a subtle difference between intent hijacking versus intent spoofing for test purposes, to identify them on the exam. Uh, Look for a non-friendly action or a trick. You're being tricked into as the receiver, um, into supplying information versus it looked like a friendly, and you'll be okay with determining the differences between intent hijacking and intent spoofing. Right, one is sneakier than the other. And then we get to the confused deputy, right? So the confused deputy, you just break out the pieces for it, right? You have app A and app B, and then you now have an app C, which is essentially on the backside of things, it's going to perform basically a man in the middle attack, right? What we would associate, classically with the man in the middle attack. The confused deputy attack occurs when the app, right, app A, the deputy has been entrusted by another app, Okay, so we can still, you still use the customer database and the sales database, right? It's been entrusted by the sheriff. The other app is the sheriff with access to sensitive data or resources. And then app C comes in, which in this scenario is the bad app that confuses the deputy, and the deputy is duped by app C or the third party into giving away access to the sensitive data that it has been entrusted with from the sheriff, right? So um, uh, it's kind of a long explanation for, basically what you have here is you're having an issue with the trust level. You have implicit trust and not explicit trust. You're not requiring the signature or system, and now trust is implied. Because you live in my neighborhood. I trust Bob. Bob trusts Sharon. So I trust Sharon, right? You have downrange trust that is being extended because I'm not explicitly requiring only these two apps can talk to each other when it comes to this data set. So since you didn't explicitly say I can only do that, now it's implied since we live in the same neighborhood that I can perform uh, this trusted action with the third application. Okay, so as you kind of can see here, um, uh, once again it's all a watershed effect. Uh, One problem leads to another, which leads to another, and if you're not constantly doing the error checking behind each iterative step of development, you can imagine how hard it is and how time consuming it can be to unwind it after the fact, right? So think about how long it took you to build it. So now, like anything else, it's always kind of harder to take it back apart and then put it back together the same way. I don't know if any of you guys are like me, right? But every time I take something apart, I always seem to have a couple extra screws. Um, you know, that's what we're kind of dealing with here, right? So building it up front, do the error checking up front, so you don't have to deal with it on the backside. Okay, so now we've defined some of these attacks. Like I said, for testing purposes, I think the hardest one to identify is uh, the issue between intent hijacking. Um, and like I said, intent spoofing, and really just be able to find the trick versus the friend, um, and you'll be okay with that. Okay, so let's go. So we'll talk briefly, really, about dynamically loaded code. Um, because dynamically loaded code, first and foremost, right, the danger of anything dynamic, right? So look at the root definition of dynamic. It's always changing. It's constantly changing. So obviously, yes, it's going to increase the possibility of code injection and tampering because it's very fluid by design. Right. It again increases the complexity of the application itself, and anytime you increase complexity, you're also decreasing security, right? I don't think we need to really deal with that or talk through that anymore. So it's important to understand that often it's you can't get around having to use dynamically loaded code, but just be prepared, right? Be prepared to secure and test any of those dynamic libraries. Don't install the code libraries in unprotected locations, right? Do not execute external code from insecure locations, right? So if you're pulling again from an RSS feed, you isolate it. You kind of put a sandbox in a sandbox to process that code before you use the result for your data processing and output. And then, of course, you don't want to specify the path to the code library, right, in an unprotected location. You always use, or you should always use, kind of a buffer zone or a no-go zone, right? The path should die there, and then you define the parameter so that it cannot be read into past that point. Okay, and that's what we dealt with a little earlier in this segment. So now moving into cached objects. Cache objects are, are in and of themselves unavoidable. You're going to have to cache data. However, there's good ways and bad ways to do this. Uh, Essentially, you must kind of at all costs avoid trying to cache data. Um, Especially sensitive data, without using encryption, right? And you want to only cache it with encryption as briefly as possible, right? So, however, you're going to have to find the sweet spot based on the architecture of the application, because you don't want to do it so briefly that you're constantly having to reload it, right? So once again, when you're having to repeat over and over again the same call action, you open yourself up to frequency analysis, and the more I can observe you doing an action, the inherently less secure it makes it, because I'll find the pattern and then figure out how I'm going to interject or interleave myself into that pattern. So it is, kind of a give and take with that specific, subject. You don't want to store it without encryption, and if you do it as brief as possible, but not so brief that you're having to continually reload it, so that frequency or pattern matching becomes an issue with the activity itself. Okay, and then lastly, you want to ensure that you restore to a secure state, right? So if your app is displaying sensitive information, um, that if the screen goes to sleep, right, the phone goes to sleep and requires unlock, it should not then unlock uh, in an insecure state, where the sensitive data is still exposed or readable, right? The user should have to re-log in to the application itself. Once again, I think that's kind of all commonplace. We've kind of talked through that at every level of security, from our late college or late high school, or even early college years on up. Okay, these next few really are nothing more than review slides for you. It's everything we've kind of already talked through. So we'll move kind of rather quickly through these. I know we're bumped up against time right now. I don't want to keep you too long, but we've gotten to the point where I wanted to, essentially, we've gotten through the meat of the session. The rest of these are just review, right? So basic guidelines for local threats, right? Excessive permissions, identify and remove unnecessary permissions. That is fairly simple. Uh, Broadcast theft. How do I deal with broadcast theft? Identify, right, the permission level. Avoid using intents at all. Make it all explicit in nature. And avoid using the sticky broadcasts, right? Since you cannot employ the protection level. uh, Intent, activity, or service hijacking. That is, it's an education issue, right? You need to educate, for instance, your users to know and to identify when something's just not right with their device, right? The system resources are tacked out, and it shouldn't have. So that's the really the hardest part. With any security exercise, is educating the users and then getting the users to use the education that that you gave them. The confused deputy, okay, once again, it's a permissions issue, right? To prevent that implicit I'm sorry, implied trust, make it explicit in nature. Right, verify the sender's identity, verify the incoming data, and you can prevent the confused deputy. Tampering with the sticky broadcast. Once again, since I can't define into permission space, um, at that point, it again becomes identifying and removing the unnecessary permissions, reducing the attack vector, reducing the attack surface to make sure that only uh, the required services and required permissions are running. Okay. Um, so here, when we deal with uh, pending intents, which we really didn't talk through or talk too much, pending intents really as long as you're not using implied and stick to using explicit intents, you really wouldn't have to worry much with pending intents. I always refer to pending intents as kind of the dangling participle, right? It's an incomplete statement, right? So as long as you're completing your statements, you really should be good there. So the last one's right. Attacker bypass the lock screen. So that's the whole point of when the phone goes to sleep. They should have to re-authenticate ID, authent, and author to the application itself that is housing sensitive data, right, to prevent them from bypassing the lock screen to access the sensitive data. Once again, dynamically loaded code. Um, it's all about going back to a secure state. You're not going to get around using dynamically loaded code, right? But the best mitigation for it is that the use of it or the employ of it is that the app is always goes back to a secure state or a lock state before accessing sensitive data again. Okay, and now this is just a reiteration of the last. So that's pretty much the meat of the evening. Okay, so like I said, these are at this point these are all review for you. Um, you know, I've made the slides available for you if you want to walk through them and highlight maybe anything that just maybe just didn't quite sit right, or from what I understand, it looks like you guys have a code review tomorrow, and Paul might be in trouble. So um, we can talk through it again on Monday. Anything that happens to come up in the code review, right? But these are all just basic bedrock best practices for you to kind of keep um, keep in the back of your mind. So the last thing that we didn't really harp on with any uh, um, uh, extended vocabulary was the exporting of data. Um, but I think we kind of accomplished how to protect the export of data, less what it is or how it happens. You're going to export data, but as long as you define it or predefine it, and then apply explicit permission to it, the exported data should not be necessarily steered away from only. Identified as the necessary evil. Now let me reduce the attack surface on it by predefining what the class state is, what the object state is, what the package contains. You must have a signature to receive the package. Once I verify the signature or the system trust and identify that both are true, then I will export data for you. Okay, so that's really all that we need to understand here. So I think what we're gonna do is we're gonna I think maybe pause or stop here. I've already gone 7 minutes past your time, and I don't want. I don't know if you guys have other activities planned for the evening or not. So we got it says 3 more slides. Um, so rather than rush through these last two, we'll just do these last two at the top of next session, which will be next Monday. Between now and then, there is a lab to do, and what I'll do is I'll go forward to that lab so you can see it. What you see here, bullet number 3, there's activities 4.2, 4.3, and 4.4. Uh, you'll get the practice of defining objects, defining classes, defining permission states, and defining export parameters through that lab. And of course, like I said, any issues that you have, we'll discuss on we'll discuss on Monday. Okay. If there aren't any questions, we'll end here, and then we'll pick up on Monday evening at 5 Central, 6 Eastern. Okay. Well, thank you guys, and you guys have a good night and a good weekend, and happy Mother's Day if there are any mothers out there. And I'll see you on Monday.